All right, it's 5 o'clock and we will get our webinar started. Want to thank everybody for attending today's webinar on asphalt and concrete inspection and preventative maintenance. This evening we have for everybody Robert Gunn, who is the founder and president of Community Pavement. And he's the only pavement maintenance company in Northern California that is specifically created to service pavement needs of homeowners associations. Robert has over 35 years of industry experience and business success. Our second presenter today, Tara Poole, is from Precision Concrete Cutting, is unable to attend due to illness, and so we will not have her be presenting. For any of those of you that have any questions, feel free to put the question in the Q&A box in the webinar, in the Zoom format, or at the end of the presentation made by Robert Gunn, we will be opening the floor up for questions that you can direct directly at Robert. Today's webinar is presented by DRYCO, and with that, I'll turn it over to Robert. Thank you, Robert.
Thank you, Tony. My name is Robert, and I'm the president, founder of Community Pavement, and our marketplace is HOAs. And the main reason for that is I wanted to work with a company where I basically would be in a position where I wouldn't need to tell the customer that they need to do pavement maintenance that I felt that actually their pavement doesn't need, at least not for functional purposes. And so this company, because of the fact we're working directly with boards, oftentimes through the manager and sometimes directly with the board members, I'm able to actually explain to them, okay, this is the way the industry is set up to do, quite a bit of work. This industry, just like most industries, has generated a great many different products, to keep revenue growing and that type of thing. But I can explain the difference between what your pavement actually needs versus for functional purposes versus cosmetic purposes. And so hopefully there'll be some fun here. There's some funny pictures in here and some funny stories. And so with that, I'm going to go ahead and get started. Okay, so my first question, or really the first thing I want to talk about, is the good news. Let me see here if I get the, there we go, is, what happens when people find out they're going to get pavement. So if you don't have pavement, if you just have dirt or whatever, usually it's pretty exciting news. It's pretty happy news. Just dirt by itself works okay. Maybe if you're getting around with a camel, or if you're just getting around on foot, something like that, you can be pretty happy camper with just dirt. But what about when you're trying to take a vehicle across it? That's a little bit of a different story. In this picture, this is a vehicle that's kind of like the third world equivalent of the garbage trucks that come through your communities multiple times, every week. They're real heavy. This one might be a little bit heavier. Maybe it might not be. It's hard to tell because garbage can get really heavy, especially when it's wet. And so if you take a look at this picture, this truck's doing fine. There's not a lot of money that's been invested in that road. But the question comes up, will the road be like this all year? And normally I would ask and see if anyone wants to give me an opinion of what the difficulty might be here. But since I can't do that in this one, I'm just going to give you the answer, which is that, yeah, what if it rains? I mean, this is obviously a desert environment, but even the desert, it rains sometime. And so they're not going to be able to get around if that water comes down. So, we all love water. It's great for playing in and getting clean and cooling off on a hot day. But when you have too much water and you mix it with the ground underneath a pavement, or if there's no pavement, the ground directly underneath the vehicle, you have issues. So here's an example of a pavement that, got some water underneath it somehow, and it created a great big sinkhole that then collapsed underneath the van here. So that right there can show you just a little bit. Luckily, we don't see this around here too much, but I mean, we get smaller versions of this. So what goes on with water, just so you understand, is that the water is similar if you've ever been on a beach and you've walked on that beach, and you'll notice that when the sand is wet, the water, the tide's out, but it's not too wet. It is nice and firm. It really holds your weight well. You might leave a few footprints in it, but then when a wave comes in and all of a sudden the wave comes around your feet, you'll feel yourself sink in. So that water actually gets in between the particles of sand and the particles of aggregate rock that's underneath your pavement, and it floats them, and they no longer support weight well. So that's basically one of the ways that water allows pavement to collapse. It also erodes the asphalt or the concrete from the top down. So if you look at your gutters, let's say at my house, we have asphalt street and concrete gutters. The gutters, if you look at them closely, they're far rougher and more eroded than the sidewalk because the gutters have to carry water, most of the year, not just from rain, but more actually from landscaping, sprinklers, irrigation. And so that has left them over the 40 years that they have been there, so that they're now, fairly rough, at least compared to the sidewalks. So basically, if you're on sand and you feel the sand and it's getting wet, you'll feel your feet sink down in. And so it feels nice on your feet, it feels nice on your tush, but how do you solve for that when you want to have vehicles, both your cars, your residents drive, but also your garbage trucks, which are the main. That's like 99% of the actual use, wear and tear that comes on your pavement from vehicles comes from those garbage trucks, moving trucks occasionally, things like that. So how to take care of that involves a little bit of complexity, but I don't want anybody to be intimidated by this talk, because even though it may seem complex on first blush, and obviously now we've had a couple thousand of years to improve our and to refine our pavement techniques, so you can have pretty complex structures. But the underlying principles that go into creating something like a modern interchange are basically the same things that people were using a long time ago. So you can breathe a sigh of relief, and we're just going to take it a little bit simpler. Instead of trying to understand exactly what all is going on, which I don't even pretend to do so on a modern interchange, we're just going to look at what is going on something much simpler, which is when humans first started working with stone. And this is from like over 11,000 years ago. This is in Turkey. It's like almost 3 times as old as Stonehenge in England. And so people were raising these huge 20, 30-ton megalith structures, and they had a stone foundation underneath. And they knew that stone lasted a long time, so that's why they built these things with stone. This is so well preserved, though. This would be much more weathered, except they actually covered this all up with dirt. The hunter-gatherers, they weren't agriculturists. They weren't people who had settled down permanently. They're actually hunter-gatherers who built this. And so after 4,000 years or something of doing their whatever they did there, or ceremonies, they covered it with dirt, and it remained covered with dirt until the last century, when it was unearthed by archaeologists. So anyhow, these are the basic principles. You have to build from good, solid material, which is going to be a hard rock like granite, and you have to put a foundation underneath it to support it. And so that's what they did here. And so we get to admire it today. And then if you want to move up into the future a little bit, still a long time ago, this is Egypt. This is from over 3,000 years ago. I took this picture. I visited this site. This is a quarry near the Aswan Dam up at the Nile River, the first place it's dammed, several hundred miles from the Mediterranean. And this was, if they had been successful to quarry this obelisk, it would have been the largest obelisk ever quarried. And if they were successful getting it down the Nile and standing it up vertical, it would have been the largest and tallest obelisk ever erected. It's like 137 feet. It's amazing. Thing weighs over 1,000 tons. And what happened is it developed a crack in it. If you look at it, you'll see the top, quarter or third of it has this huge crack in it. So they were, chiseling this thing away, all with hand tools, and not even iron, not even steel tools or iron tools, using bronze tools. It's incredible, the patience exercise. And then it developed that crack. So, on the day that crack developed, the workers probably went home early, and they just had a good laugh saying, okay, we can take a break. We'll have dinner early and relax for a little bit, and think about maybe coming up with a better way of how to do this stuff. And so it did happen. The next group of people I have some pictures of are the Romans. This is a Roman road. It's like an over 2,000-year-old road. And you see they're working with a lot smaller stones here. And so this road was in use up to like a little over 100 years ago. Now it's an open air museum, but you can see the wheel ruts in it. And to last a really long time, this thing was used continuously for many, many centuries. And the Romans, they worked hard at perfecting their road building. They took solid stone blocks, and they put them on top of a foundation that they created after excavating the native dirt. So they wanted to have nice, solid foundations. So they got rid of the native dirt, which is usually either too sandy or too much clay, which both have issues. and then they crown their roads, and so that the water that would hit it would run off into drainage ditches and not undermine the road. So they put a lot of work into this. They needed to move their legions. Was the main reason why they spent all this money on this. That way, they could have troops cover a much bigger area than they could cover if they couldn't move quickly. So, the military industrial industry was strong back then, strong today. So this right here is a really good road. Be fine for everything the Romans wanted it to do for. But what about, a little more modern period? We have different things like fast moving vehicles, faster than just a carriage. And, we have things like roller skating. So what happens, if you want to roller skate on your surface, those stone blocks wouldn't be so comfortable. So anyhow, the way we ended up, perfecting our method of building pavement, both concrete and asphalt, is instead of working with those big stone blocks, either the huge stone blocks from a long time ago or the small stone blocks that the Romans used, big enough that one or two people could pick them up and move them, we got the bright idea to use very small stone, crushed stone. And so, in modern pavements, the stone's crushed at a quarry. It's actually crushed a lot smaller than these stones here, but it's crushed down so that it's easily moved around, moved with conveyor belts, and then it's moved by trucks or ships or trains, however, from the quarry to the plant, the concrete plant or the asphalt plant. A lot of times those plants are situated on top of the quarry, and then they mix it with one of two things. Either they mix it with cement, and so then that becomes concrete once water is added to it, or they mix it with something called bitumen, which we typically think of as tar. And so that is the black sticky stuff that the dinosaurs got trapped in at the Brea tar pits, like down in Southern California. And so that's just a naturally occurring bitumen. The way we get our bitumen is it's a byproduct of distilling crude oil for when you get the gasoline and diesel and the various things that are lighter, the volatiles off of that crude oil. What's left at the very bottom of the barrel when they cook it all off is this tar, this bitumen. And so this stuff is mixed. It's liquid, and when it's heated up to a couple hundred degrees, it's solid at room temperature. They mix it with those rocks to make asphalt in a big drum that spins it and gets it really hot, 300, 350 degrees. And then it's put down in your parking lot or your street and compacted. And the way it gets hard is it just cools off. So that's basically as simple as it is. There's no chemical reaction like there is in concrete. There's no crystalline structure that sets up from the cement or anything like that. It's just that bitumen, that tar cools off and it becomes a solid. And the compaction means that there's less air voids in that solid, which is something you want to have it last longer. And then after that, that's it. On 100 and triple digit day, it will get soft again somewhat. So if you park like a motorcycle with a side kickstand and it's leaning over and it's a heavy motorcycle and it's a really hot day and the sun's heating that asphalt up, then that kickstand may sink into the asphalt and fall over. But other than situations like that, the asphalt, it's stable all the time just because it's cooled off enough after the initial placement to stay there stably. So then the question becomes, okay, why is asphalt deteriorate more quickly than concrete? Why does asphalt need to be seal coated and concrete doesn't? Well, this bitumen, this is a petroleum product. And so petroleum products break down much more quickly than the crystalline structure of cement that holds the concrete together. The cement's the binder, the concrete's the overall product, and you have the binder mixed with the aggregate, the rock. And so there's a couple different things that break down tar bitumen. One of them is UV rays, is the sun. And so, we have to protect our eyes from those UV rays. And so UV ray breaks down petroleum products really quickly. If you see plastic that's just, getting shredded in the sun, that's what's going on. Plastic's made from petroleum and it just gets shredded very quickly when it sits out in the sun. And so you actually, with plastic, we just throw it away, of course. But with our pavement, we want to protect it. Another big thing that wears out pavement in HOAs in particular is water. And so the reason why I say HOAs in particular is, because the water, of course, falls everywhere pretty much equally, like in this area. We're in this area, we're in a semi-desert climate here. And so we actually get very little rain. We have lots of water because we have the snow in the Sierras that, give us water year round. But as far as actual rain goes, we're like maybe 15, 16 inches a year. I mean, rain is great stuff. We love it. But water can be very hard on pavement. And so, when it's raining, it feels really good to me because it means I can take a break from, doing my work. But it doesn't rain that much. But what it does do a lot in HOAs is HOAs have a lot of water coming from irrigation, from sprinkler systems. And so that water, especially here in Sacramento where it's so hot and we have such a long warm season, for 8 months out of the year, we're running our sprinklers. And so that water runs in certain places in the HOA across that pavement, 3, 4, 5 or more days a week for however many 8 months, 7, 8 months out of the year. And that water is very, very corrosive on asphalt and concrete both, but much more so on asphalt than concrete. And so we have to protect the pavement from that type of erosion, which is what seal coating is about, which I'll get to in a minute. The other form of water that's an issue is water that's very destructive. It comes underneath pavement or it comes on top of pavement. This right here is water from the Outer Banks in either North or South Carolina. And it's just breaking this road up. You can see there's two different kinds of cracks in this pavement. And the crack underneath the yellow center line, you see how it's like a zipper there, so straight? That's called a cold joint crack. You have them typically in most HOA pavements. Once the pavement's aged more than even just a few years, it starts showing up. The reason why that's there is because the street or the road was originally paved in 2 passes. The paving machine is not big enough to pave it all in 1 pass, so 1 lane gets paved, and then that lane usually cools off quite a bit, and then maybe the next day or some other time they come back and pave the other lane. So where those 2 lanes meet is what's called the cold joint, and that's a weak area in the pavement. So those two pieces of pavement, they don't really bond well to each other because they cooled off and they weren't put down in a uniform fashion. And so then they split. You see the split in your pavement in your streets, and then of course here we have a really big dramatic split. And so that's something that we can address with crack filling, which we'll also talk about, and I'll answer questions about. The other kind of crack there, that's more, it just ripped apart, and we see that's from ground movement. Here it's really dramatic, super accelerated by the water, but we see a lot of that in this area. There's a lot of ground movement. We have a lot of clay soil that expands and contracts, which has a picture or two about that. I'll talk about that too for crack filling. Okay, so close up of pavement. There it is. There's some pavement that's pretty typical in that it has some oxidation going on. It's no longer black like when it was, new with that bitumen. The bitumen, a lot of it's evaporated off. It's got cooked off in those UV rays, also oxidation in the atmosphere. And then it's also had water that's come across it from rain and from irrigation. And so it's made it rougher. Those little pebbles you see out there, that's not dirt or junk that got kicked in from like the landscaping. That's actually the asphalt. Those are part of, what's called the aggregate that the bitumen was gluing together, and now they're popping loose as the bitumen is breaking down, and this pavement's suffering a bit from not having been seal coated. So the good news, though, about this process is that it's not very expensive to seal coat. And on top of that, there's a secret I'm going to let you folks know about that I kind of alluded to earlier when I talked about, one of my big motivations for starting this company, to have my own company, which is that you actually don't need to seal coat as much as the pavement maintenance industry would like to see you seal coat. So that's what's being told to this young man here. He's getting to find out about the secret that's similar to the oil change in your car. You don't need to do it as frequently as the oil change companies will want you to do it. I mean, they want to have revenue, and so they encourage you to change the oil more often than you need to. And the reason why the state of California has gone to the expense of advertising to people, don't change your oil so frequently, is the state of California has a big environmental expense of getting rid of all that used motor oil. And so that's why, they're trying to tell you, look in your owner's manual and find out what it says as far as how often you need to change that oil. It gives an example here of oil change 8,500 miles on that sign. So they're usually going to tell you 3,500. They're a little better now. I think they tell me like 4,500 or 5,000, but my manual is 7,500 for my vehicle. So similar to that, the pavement does not need to be seal coated. The reserve study says it's every 5 years. Typically, everyone I've ever seen says that. And I would agree with that for the first 1 or 2 seal coats. But after that, unless there's a lot of water erosion from irrigation, they really don't need more than that based upon the amount of normal, just rainwater, normal or natural precipitation they get. And seal coating does nothing for heavy loads, those kind of things, which I'll talk about in a minute. So it's pretty much your main thing it's there for is bad oxidation from the atmosphere, UV rays, also motor vehicle fuels. You got a lot of leaky cars, that kind of thing. Transmission, brake fluid, that's all real hard on asphalt. And then water from sprinklers, so irrigation. That's the stuff we're trying to protect it from. I could come out and look at a pavement and I could tell you, okay, you really whether you really need to seal coat or not. We're talking now about functional reasons. Cosmetic reasons is different. I mean, pavement always looks better when it's freshly seal coated. A community looks better when it's freshly seal coated. So for that reason, property values or just the image of the community, how you want to feel about it, then sure, seal coat every 4 or 5 years. Okay, so I'm going to move on to the next slide here. And so there is another really piece of good news about maintaining the asphalt pavement, which is that this is a reaction when people hear this piece of good news. So I want everyone looking like this. I want to tell you the good news, which is that your vehicles, your cars help maintain your pavement. And I got to explain real quick why that happens. Okay, it goes back to that bitumen, that tar. So that tar is mixed around all the rocks in a big drum with jets of natural gas, blowing in there, heating the whole thing up to 350 degrees, and then it's put down and it's compacted and it just sits there. However, it doesn't sit there and nothing ever changes in it, because as your cars drive over it, those cars actually, and that it's wrapped around all the aggregate. That's for the picture again of that. Your cars actually need the asphalt, need as in, well, they need it to drive around and not get stuck in the mud in the winter, but also they need it as in KNEAD needed. So the actions of the tires help pump the bitumen through the asphalt, particularly during warm weather, so that it circulates. And so you bring up fresh bitumen to the surface, which that bitumen gets, like I said, oxidated off, UV rays cook it off. And so it circulates it the same way kneading dough does. And it's great. And if you look at a pavement, the worst pavements you're ever going to see are pavements that are in parking lots or streets that no longer have traffic. The business is closed and the thing's boarded up, and you'll see weeds come up and you'll see it get super dry and super gravelly. And it's really bad for pavement to not have, I'm talking about asphalt pavement, to not have vehicles driving on it. And so that, is good news. You people are driving on your own pavement, you're helping maintain it. It's one of the reasons why you really don't need to seal coat as often as they say that you need to seal coat once those first 1 or 2 seal coats have been completed in those first 10 years. Okay, so I'm sure I'll have lots of questions about that, which you can ask in just a few more minutes. I'll shut up. But now I'm going to move on to the whole other issue that pavements have to deal with, and that is heavy vehicle loads. And so this right here, is a super heavy vehicle load. I don't know how much it weighs, but it probably weighs more than the garbage trucks your pavements are experiencing, okay? And so this breaks pavement over time. Pavement has some flexibility to it, particularly when it's new, but as it gets old, it develops some brittleness to it. And so it will tend to break over time, particularly HOA pavements and parking lot pavements that are built to basically kind of the minimal amount of asphalt needed to hold up to garbage trucks for some period of time. Your reserve study is typically anticipating 20 or 25-year lifespan for your pavement. And the reason why it's only 20 or 25 years is because with asphalt, typically they put 2 inches down, sometimes it's 2.5 inches, over 4 inches of a crushed base on top of some native soil. And so that's, kind of like I said, the minimum amount of pavement to last. With concrete, they put 4 inches down. Again, that's like a minimal amount of concrete. Concrete's quite a bit more brittle than asphalt. It doesn't have the flexibility that asphalt does because of the nature of the cement that binds the aggregate. And so it has to be 4 inches thick. It's much better to have concrete be 6 inches thick. And if anyone ever wants to not have to maintain their asphalt pavement again, then you switch to concrete. If you really want to, you're eager to spend some money, that's the way to do it. Just abandon asphalt and put in 6 inches of concrete with reinforcing steel, and you won't have to do anything to that concrete for at least 100 years. So that's the way to go, but it's expensive. And there's reasons why builders, do just the asphalt. Okay, so then you end up having a bit of a dog and pony show with pavement maintenance contractors because that asphalt does crack. They will go into HOAs or whatever pavement parking lots, and they'll say, well, okay, it's cracked. We need to tear it out, and put back new asphalt. And that's just really not being fair to the owners of the pavement, because cracked pavement actually works 5% of the time. It works just fine for supporting vehicles for its functional purpose. Okay, the exception for that is when the cracks join together and the pieces become smaller and smaller, and they start popping. They start becoming loose, and then eventually you'll develop a pothole. Okay, and so when you have a pothole, you're going to want to take that area out and replace it with some fresh asphalt. And typically, we're going to the industry standard is replace it with 4 inches of asphalt, since the original asphalt was 2 inches or 2.5 inches, and it failed in that area. Typically, the areas that fail are areas that have the native soil is softer underneath for whatever reason, and so they don't support the asphalt as well. When the native soil is good, strong soil, or was engineered that way by the developer who constructed the street, then typically that asphalt will never fail, sink down into potholes. It'll gradually get more brittle and more rigid and more prone to that cracking, that fracturing is called, or block cracking, the engineers call it. But it still holds together. And it's just a question of eventually at a certain point you put a new lift of asphalt on top of that. But but you don't need to like tear everything out. It's crazy to do that. The HOA, the residents have already spent a large, have written large checks, even though it's not in the form of a check to the contractor who built the streets, but it's in the form of the price of your house. Your streets are a very large investment. Everyone's already paid for that pavement. You don't want to have to pay a contractor to tear it away. You want to go on top of it. That's what all the municipalities do. They go on top of the pavement with something called an overlay. And that's the way it's addressed to fix a pavement when it's actually at the end of its life. An overlay can address a lot of issues in addition to addressing this block cracking, the heavy loads from the garbage trucks, and also addressing that erosion and that roughness that comes over time from the water and the sun. It also can address, if it's engineered properly, if it's designed properly, ground movement cracks. Ground movement cracks are probably one of the things I get the most complaints about from HOA board members and from residents. People do not like seeing big cracks in their pavement. They're unsightly. I agree with that. And if they're big enough, they're actually trip hazards. So there's a couple different causes of those kind of cracks. The main one is expansion and contraction of the underlying soil. So underlying soils are typically clay dominated, and so as they get wet, they expand, and as they dry out, which happens during the summer, they shrink or contract and cracks form up. That's what you're seeing here. There's no pavement here, but you can see it clearly in the soil here as it dries out. And so those cracks come up through your pavement, and then we will try to do crack. When I say try, we put the hot crack, we fill them with sand and put hot crack filler in. But when I say try, it's because we don't guarantee that, and no pavement maintenance contractor does, to not reopen, because we can't get that crack glued shut by using fillers into it. If it decides to, the ground underneath to move, the pavement to move, then the crack reappears. The main idea behind the crack filling is to prevent water from running into the cracks. But again, like I said, where we live in a semi-desert environment, the amount of water that splashes into those cracks is pretty minimal. It's just, your streets are sloped if you have streets, and versus parking lots. And the water hits it, and the water runs off very quickly into your gutters and into your catch basins. It just does not spend much time on the pavement. And so very little water goes into those cracks. So that's why on my proposals, I put the crack filling as an optional item. It's like the holy grail of pavement maintenance is that if you crack fill your pavement's great, you have to crack fill, but I really don't see that type of benefit from crack filling. It's definitely a very important decision to make politically, because if you don't crack fill, there's oftentimes a lot of complaints. Why, these cracks, they did a horrible job. There's still these cracks in it. People want to see the cracks go away. Now the cracks will be back again in 6 months, but by then everybody's forgotten about the fact that they just still go to their parking lot. It looks pretty much like it did, before their streets. And so, you just don't get a lot of mileage out of crack filling. So that's why it's an optional item. We're happy to do it. It certainly looks a lot better when we don't do it. I'm always nervous. I know there's a good chance I'll get complaints if we didn't crack fill. So I definitely feel it's my duty to have a crack filling item on the proposal. But I make it as an optional item. I have a base bid, which is like seal coating and striping, and any safety issues, that's your base bid. And then, crack filling is one of those things that's optional, because it's primarily, I believe, a cosmetic treatment, at least in our climate here in Sacramento, and at least for areas where the pavement is well sloped so the water drains off. If the pavement is not well sloped and it's holding a lot of water, then maybe the crack filling makes more sense. Because water ponds, and they'll keep less from running into the base while you're waiting for the water to evaporate out. So anyhow, there is a really good product though that addresses cracks. Oh, there's one last slide I forgot about. This is the final kind of cracks I want to talk about. These are just like when the earth just decides to move. They say when the World Series earthquake hit San Francisco, when the shift hits the land, there's not a lot you can do about it. This is down in Mexico. This thing goes on for miles. This is just a still shot, but there's actually video of a plane or a helicopter or drone, flying over this thing. It just goes on and on and on. It just opened up, split this dirt road right in two. So you get ground moving cracks that sometimes there's the only way to, if you really want to take care of it, is you got to dig out and pave. And so I can do that. We can do that. Other contractors can do that. We use fiberglass when we pave over cracks like this. We only go down halfway. We leave half the pavement still there. We grind down that way. With a grinder, we can just take off an inch or an inch and a half of the pavement. We lay a fiberglass mat down. So that's like a big Band-Aid, holding that crack. And then we put hot asphalt on top of it. It still will crack, but it doesn't crack as big. It doesn't have the big trip hazard crack. And it takes a little bit of time, a couple of years, starts to crack again as the ground moves. With tennis courts, there's a much more involved process we do. It's much more expensive. It actually comes with a guarantee not to crack, 2 years from the manufacturer. And we add a third year on to make it 3 years. So you can get 3 years guaranteed. That's on a tennis court. You don't have to deal with garbage trucks and things like that on tennis courts. Okay, so anyhow, the last thing is about what the gold standard of taking care of your pavement when you've done some seal coating, you've done some, if you have any potholes, you've taken care of that. But if you really take care of it, and then the gold standard is finally to do something called an overlay. And so that's just like taking care of your teeth. If you take care of your teeth and brush them and get your fillings and stuff like that, eventually, you will need to do when you get old enough, something more substantial than that. And so, but it should go a long time, maybe just like your human teeth, maybe, 50 years before you have to start getting implants or something like that. I got my first implants, I only have two, a couple of years ago, and I'm 61 now. So, they lasted a long time without having to get something significant like that. And that is this overlay I've talked about. It's on your reserve studies, typically at year 20 or 25. And your reserve study says overlay with fabric interlayer. And so what they're talking about with the fabric interlayer is they're talking about this product. Well, they're not talking about this particular product, but they're talking about a generic group of products where a fabric is laid down on top of the pavement. It's laid down in a thick coating of bitumen, a special bitumen. It comes out of a distributor truck. That's what you see in this picture here on the left. And it's hot, just like, it's 400 degrees, just like the stuff at the asphalt plant. So the truck puts that tar down, and then the truck also rolls out the fabric into it. And that sets up, again, like a big Band-Aid across your pavement, and it prevents cracks from coming up through. And it used to be there was pretty much just one kind of paving fabric, a polypropylene-based paving fabric, which just means it's a nylon. It's like your fleece sweater. And the brand name was called Petromat. Petromat's like Kleenex, it's an actual brand name. Tissue, facial tissue is a generic name. So paving fabric's a generic name. Petromat is the brand name. But since Petromat came around in the 1970s, I think, a couple of years before I got started in 1983 in this industry, they've come up with fiberglass-based products, and that's why Owen Corning is now in the business. They make a fiberglass paving fabric called TruePave, and it is great. There's another company that makes one even better than Owen Corning. They came along, I think, after Owens Corning, but it's a little more expensive product, but it is even better than Owen Corning. This stuff is super tough, super strong. It's super cheap compared to that digging out that the pavement maintenance contractors want to do. Really cheap compared to that. And you put this down, and then you put a couple inches of hot asphalt on top of that, and you have a road that it was better than when it was new, because now your road, since you didn't, let some contractor talk you into tearing it all out, now you have your 2 inches of original asphalt, and you have 2 inches of new asphalt, and you have fiberglass across your whole road. And so it's a really, really heavy duty surface that you can drive lots of heavy vehicles over, and it'll last a long time for you. And you did not go to all that extra expense. And for me, it's a lot more than about money. You didn't go to all those extra carbon emissions of tearing all that out. I mean, it's crazy. We cannot do things the way we used to do it. Now we know, we're no longer ignorant, that we cannot just burn all these fossil fuels to do all this stuff that's wasteful if we don't really need to. And we don't need to tear out a bunch of pavement. We can just pave on top of it, and then we can all breathe a little bit easier, And that way, all these little kids that you saw on the slideshow, when they're old enough to understand these things, they'll thank you for making the wise decisions, and say, hey, let's just not go overboard on this. Let's just be responsible stewards. And if the contractor's saying we don't need to do all this extra expense, which expense exactly equals carbon emissions, then why don't we maybe give that a try and see how it works? Follow our reserve study. And the reserve studies also, they're being very conservative, saying year 25. Typically, it's probably gonna be more like year 40 or 50 that you really need to do that type of thing where you put your overlay on. So okay, I think that is the entire talk, and I'm going to open it up to questions now.
So Robert, we did have a question which was answered in your presentation, but I'll go ahead and present it to you now if you want to add further details. We had one of the attendees ask, pavement needs seal coat every 1 year to help with the wear, and every how many years after?
Yeah, the seal coat, typically it is good to seal coat it within the first year or two of being constructed. And then after that, I would say the 5 year spacing on the reserve study is appropriate for the first 2 seal coats after that. So that would be, year 5 and year 10, or year 6 and year 11. And then after that, it depends on how much water is hitting the pavement. So the more water that hits it, then you might end up needing to do it every 5 years if enough water hits it. I've never seen an HOA do it, but in theory, you could just go in and seal coat the areas that are getting all that water erosions running across it, and not seal coat the rest. When we're seal coating, typically, the majority of the pavement we're seal coating does not need to, meaning in any particular one project, the majority of the pavement does not need to be really seal coated that year. But there's always going to be some areas that really do need it, because those areas are the areas where a lot of water runs across, and like I said, maybe 8 months out of the year. So it's, but I've never seen anybody do that and just seal coat part of it. Again, a lot of it's political decisions. People are going to ask, well, why did you guys only do that instead of the whole thing? And seal coat's not a really expensive product. It's typically somewhere between 10 and 20 cents a square foot. And so, it's not like a big money like we're talking about with all this asphalt paving prices.
Great, thank you very much. If we have any other questions, feel free to add it to the Q&A, or if you'd like to ask it live, please feel free. We have another question here. Can crack treat stop or prevent potholes?
No. Yeah, so that, and the same with seal coat. So potholes are a function of heavy weights on pavement. And so potholes, I mean, in theory, the crack filling could perhaps slow the progression of the pothole, by keeping, water out of the asphalt. But typically, we're not even looking at what we do. Potholes are something that come about when you have something called this block cracking. So that's also called alligatoring colloquially. So it's a bunch of small blocks of asphalt. The cracks are in block patterns like the back of the alligator, the back of the crocodile. And typically when pavement maintenance contractors are crack filling, they don't even crack fill block cracking cracks. Those block cracks are very tight, they're very narrow. And if you look at the proposal, typically the proposal is going to say cracks a 1/4 inch or wider. So 1/4 inch or wider, those are ground movement cracks that open up like that. You'd be wasting your money trying to have block cracking hot crack fill because it's so narrow you can't even get the hot crack fill material to flow into those cracks. So the ground movement cracks open up wider, so they're wide enough typically to get the material to go into. If they're a little bit wider still, they're wide enough for us to put sand into. And so when I see those cracks, my proposal will say we're going to pre-fill with sand. That works even better. The sand helps support the hot crack fill material. The hot crack fill material tends to run down into the crack. Even after it cools off, it runs down overnight and over the next day and just over time. And so really quickly, it doesn't look like the cracks were crack filled. So basically, for when you have potholes or when you have that alligator cracking and it's starting to sink down, it's like it's going to turn a pothole. At some point, if you don't want to overlay the whole thing, which usually you don't have to, you're just going to have to do one of those 4-inch remove and replace patches in that area to address that when you're ready to.
Great.
Yeah.
We have a hand raised. Michael, if you'd like to ask a question. Michael, you are muted.
Unmute, sorry. Have you heard of the Caltrans aggregate seal coat mix? With it goes up to 3 inches?
Yeah. What was the last thing you said? I'm sorry. The Caltrans mix and aggregate mix.
Yeah, it's supposed to be able to go up to 3 inches thick. What's your knowledge on that there?
Okay. I thought you were going to talk about the Caltrans slurry, which is like the Caltrans. They have it's referred to by the page number in the Caltrans manual, which is 37.2 slurry. And so the ones I'm familiar with are all slurry, so they're all thin. They're thicker than seal coat, but they still have a very small aggregate. Seal coat uses a sand aggregate, and the slurries use a small pebble, like a 1/16 of an inch, 1/8 of an inch diameter pebble.
Yeah, this said they could go up to 3 inches. It showed a rock mixture aggregate in it, rather than just a slurry coat. It was a seal coat that they could run over, certain areas to help. And they didn't know what it says. They last 7 to 10 years.
Mm-hmm.
And
yeah, the only thing I'm familiar with that can go up into the depths approaching an inch or a couple inches, that would all be asphalt, asphalted concrete mix.
okay, now what could we use? Because out here we have gyp seal on top of everything. That's it. We don't have any paving. We got rock.
Yeah, sure.
And
Yeah,
we
the
get
chips,
30 inches of rain plus a year.
right. Yeah, the chip seal is from older pavements, when money was scarcer or just they were more budget conscious. And so they put a base rock down and then put chip seal on top of it. And so it gives a good workable surface and it lasts a long time, but it doesn't last as long as asphalt. Basically, it's just because it's just not that thick, like you said, it's like 3/8 of an inch or something like that. So you kind of have two choices with that. One is you can do more chip seal on top of it. You can even use a paving fabric and then put chip seal on top of the paving fabric. And so I've worked with that product before, and it's a good product. It's a little messy because the chip seals, they tend to delaminate somewhat. Some of those chips pop loose over time, more so than with asphalt. And so you have to have residents who are going to be comfortable with that. Otherwise, you can just go ahead and tack meaning put a binder, that bitumen binder down, and you can pave either with or without fabric with hot asphalt.
Okay.
Great.
All right. Yeah, we're trying to figure out what to do to repair our roads and be as cost efficient as we can because there's no money in the budget to do the repairs.
Yeah, the most cost efficient is to stick with chip. Though the chip seal, to get a good price on that, you really need to have a large quantity. because it's a bigger operation. It takes a lot of equipment, and the unit cost will be very high if you're just trying to do like one street, unless it's a really big street. So you would want to like budget and then say, okay, every whatever it's going to be based on your budget, 5 or 10 years, we're going to let out a large amount to contract, and that way you can get your best prices for your chip seal.
You talking a couple 100,000 square feet?
Yeah, I would think like at least 100,000 square feet to
Okay.
get in. You know, the prices won't drop so much once you get over that number, but somewhere around there exactly. That's what you want to get yourself a unit price that's, you know, that's almost as low as it's going to be.
All right, I thank you.
Yeah, sure thing.
Right. Thank you, Michael. Next question we have, Robert, is does water intrusion into cracks deteriorate aggregate base layer, which leads to asphalt failure?
It does, yes. And so that's why the big emphasis on crack filling. And so, because if you have enough water running down on the crack, it will eventually carry aggregate away as the water goes to wherever it's going to, and undermine the asphalt. But as far as how much I actually see that in this area, very, very little. I mean, typically when we see that, it's just like in a very isolated area, and it's because like a utility patch was done and they didn't compact the asphalt. I mean, the aggregate well when they put or the dirt well when they put the, you know, the material back in the ground after they finished fixing, you know, the water line or the sewer line or whatever broke down there, and then you get this erosion and you get a sinkhole. But as far as when they're actually building the roads or building the parking lot, and they have all the, you know, the heavy duty equipment in there, and they, you know, they mix the dirt with water, and they have an inspector out there, and they're using density gauges to measure the density of the soil or make sure it's all compacted well. And then they put the base rock on top of that and get all that all compacted well. And they put that finally the asphalt on top of that. And then, you know, that thing eventually will develop some cracks, but the amount of water we get is just so minimal. I just haven't seen it where we're getting, you know, undermining from that type of water going into cracks.
Great, thank you. Do we have any more questions? If you'd like to answer, drop a question in the Q&A or raise your hand, please feel free. While we wait, again, I'd like to thank DRYCO for being our presenting sponsor for this webinar. And again, I'd like to thank Robert for the fantastic presentation, lots of good educational tidbits in there and good historical information in terms of the genesis of asphalt and concrete work. It was very interesting.
On a concrete street, if it lasts longer.
Oh yeah, well, concrete's the way to go. So if you can afford the upfront costs, it's definitely the product. And I should add about concrete that I do in HOAs that have a lot of concrete sidewalks and things like that. I do refer them over to Precision, Tara's company, because they're specialists in that and going through, and they do a very, very thorough what they call survey or evaluation, where that's all they're focused on, and they go through and they look at all the concrete and they check everything and they measure every little trip hazard. So they give you a list of how many trip hazards are 1/4 inch and how many 1/2 inch, how many 3/4 inch. It's very impressive. And I've never had the patience to try to do that. I just say, okay, if you have that much, you know, concrete to look at, just go ahead and pass it over there. We do grind down concrete trip hazards. We do that, and we replace concrete when it's too lifted up by roots and that type of thing. So that's part of our work. But you know, it's particularly in, like I said, large associations with lots of footpaths. They are, and because they're set up to handle the municipalities. So they, you know, look at the municipalities might have like 100 miles of sidewalks, and they're geared up to take care of that, and then go in and grind it all down and make it so that, you know, the municipalities don't have these liability issues.
Thank you, Robert. Do we have any other questions? Please feel free. All right. Looks like you've answered all the questions, Robert. Again, thank you for your time this evening and your fantastic presentation. For those of you who attended, this is being recorded and this will be hosted on our YouTube channel. You can access that through Association Management Concepts on YouTube or via our website. It will take about 3 weeks for this to be compressed and set up so they can be hosted. At which point it'll be available, like I said, on our YouTube channel, accessible through Association Management Concepts or through our website. All right. Well, with that, we will conclude tonight's webinar. Thank you very much, Robert. Thank you all for those that attended. And we look forward to seeing you at our next upcoming webinar and or seminar, whichever you're able to attend. Look for the email sent out by us to notify you of what's going to be coming up, and feel free to register and tell your associates on the board and how great and informative these things are.